Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to try a few problems regarding the Laplace transform. And let's see, before we do that, let's do a little recall. We've said in general that the Laplace transform of some function f of t is equal to the integral from 0 to infinity of e to the minus st times f of t dt. And what happens then is when you evaluate this, the t goes away, you're left with a function of s. And we said a few other things, as we said that the Laplace transform then of y prime of t, we found this using the integration by parts. We used this, gave us s times y of s minus the initial condition y of 0. And our last one we had is the Laplace transform of e to the a t is equal to 1 over s minus a. So here's the problems that we're going to try today. We're going to use what we have. We also said that the Laplace transform is a linear operator. Well, what does that mean? That means if you take the Laplace transform of a times f of t, well, that's the same as factoring out the a, then applying the Laplace transform to the function of t, and so your result would be a times f of s. Okay, let's try some of these. So the first one I thought we would try is we're going to find the Laplace transform of just some simple constant. Yeah, a is just a constant. Well, let's think about this for a moment. If a is a constant, I would factor it out. So that's a times the Laplace transform of 1. But we haven't found the Laplace transform of 1 directly. But we found it indirectly in that this is the same as saying a times the Laplace transform of e to the 0 power. Well, we found the Laplace transform of e to the 0, or e to the a. Well, that's just 1 over, it's going to be a times 1 over s minus 0. So in other words, we can clean that up as a over s. Okay, so let's try this. Our second problem is we're going to solve y prime minus 5y equals 3. So the first thing we're going to do is we're just going to transform this. So let's see, transform the differential equation. All right, so if I apply the Laplace transform to every term, so Laplace, I'm actually applying it to first the entire to each side, just like you would expect. Our algebra rules always still hold. So this is going to be, because it's a linear operator, it's the Laplace of y prime minus, and I'm going to factor out the 5 and just take the Laplace of y, and then on the right, I'll just rewrite that again. Well, actually, on the right-hand side, let's factor out that 3. That's just the Laplace transform of 1. Okay, now let's apply our Laplace transform. So we can say this is s y of s minus some initial condition y of 0. Oh, and I want to give our equation let's try y of 0 equals 2. Let's just try a number for a change. Yes, gee whiz, 5 times the Laplace transform of y of s. This is equal to 3 times the Laplace transform of 1 is 1 over s, and so I'm going to move the y of 0 to the right-hand side and factor y of s. So I have y of s times s minus 5 equals the y of 0, which is 2, plus 3 over s. And my last step, just to find the transformation, would be to divide. So I have y of s, divide by s minus 5. So this is going to be a 2 over s minus 5 plus 3 over s times s minus 5. Okay, that would be the transformation, the Laplace transform of our differential equation. So the third thing we're going to do, number 3, is we're going to transform, or take the inverse, apply the inverse Laplace to y of s. Well, meaning you're applying it to both sides of the equation. Now, before we even get started, we have a problem. The problem is we don't have this s times s minus 5 doesn't fit any of our patterns. So what we can do is let's apply partial fractions and see how we can clean that up. So that is I'm going to write this out. So this is 3 over s times s minus 5. This is equal to, I'm going to write it as a over s plus b over s minus 5. And then what I'm going to do is I'm going to multiply both sides by the common denominator. So this becomes 3 equals a times, the s's will cancel, so a times s minus 5 plus s minus 5's will cancel, so I'm going to have a b times s. Now let's solve this. I'm going to do it, you can do it a few different ways. I'm just going to say let s equal 5. Okay, so if I do that, then the first term becomes 0. So then what do I have? Then I have that 3 equals b times that 5. Or in other words, we can say that b is 3/5. Okay, and then let's try again. Let s, in this case, let's let s equal 0. So then the b term goes away. So now I have the problem of 3 equals a times 0 minus 5. So we can say that a is equal to a minus 3/5. Now we can apply the inverse Laplace transform, and I'll write it out because what we're applying it to is capital Y of s equals 2 over s minus 5 plus, my a is a minus 3/5 over s, and my b is a positive 3/5 over s minus 5. Apply the Laplace inverse to every term. When we do that, we get y of t equals, now remember the 2 is just a scalar, so that doesn't affect the Laplace transform. We're really looking at, you know what, let me write one more step. We're really looking at 2 times the inverse Laplace of 1 over s minus 5. And then we're going to have a minus, I'll write it that way, minus 3/5 times the inverse Laplace of 1 over s. And then we're going to have plus a 3/5 times the inverse Laplace transform of 1 over s minus 5. And now we can do that. So we can say that y of t is equal to 2 times the inverse Laplace of s minus 5 is just e to the 5t. E to the 5t. And really all we're doing is we're applying this Laplace transform principle right there. So you notice I have minus a, I had a minus 5. So in other words, I just put in a 5 in the a position on the exponential. Okay, so let's do that. What do I have? Minus, well, the inverse Laplace of 1 over s, that's just e to the 0, so that's just 1. That's just 1. And so then this just becomes a minus 3/5. And so let me go back to that really briefly here. So the inverse Laplace of 1 over s, well, that was this right here. But that came from e to the 0. Well, e to the 0, that's just 1. There it is. So then now we can move on. And our last one is going to be plus 3/5 times, again, we have 1 over s minus 5. Its inverse is e to the 5t. We can combine like terms and say that this is the same as 13 over 5 e to the 5t minus 3/5, assuming I did my arithmetic on that fraction correctly. I hope that helps. Thanks for watching.